Calculus AB. We're talking about 1.4 from our openstax textbook, and this is checkpoint 1.21, where we're looking at integration formulas and ultimately the net change theorem, which is not the purpose of this video, but we're talking about how it will be part of or using some information we already know. Checkpoint 1.21 says, find the definite integral of f of x equals x squared minus 3x over the interval from 1 to 3. It's a closed interval, and the function itself is continuous and differentiable everywhere in that interval. So we can use fundamental theorem of calculus part 2. By the way, what I just said right there, I might not always write down, but it is good to be considering. There are times when a function is not continuous or is not differentiable over the interval, and we have problems. And I think we're going to get into how we address those problems as we move forward in this curriculum. Okay, let's take a look at the problem though. So here we have it. We have x squared minus 3x. If you remember the second part of the fundamental theorem of calculus, we could find the antiderivative of each of these pieces. So maybe like the long way of writing this out would be the definite integral from 1 to 3 of x squared dx minus 3 times the integral from 1 to 3 of x dx. Notice that we can break apart an integral if it's like a, terms that are added together or subtracted. And we can also move any coefficients, any constant coefficients out of the integral itself. So like negative 3 can pop out. Now, okay, so what is the antiderivative of x squared? Add 1, flip it, there you go, from 1 to 3. Minus 3 times the antiderivative of x, it would be 1 over 2 x squared. You add 1 to the exponent, make it become the denominator, and also the new exponent from 1 to 3. This is a little bit blendy, if you'll allow me to, make up words. This is a little bit blendy of notation, so let's just go ahead and move into actually applying the fundamental theorem of calculus, part 2. 1/3, 3 to the third minus 1 to the third. Notice that this right here, oh, there we go, we resolved the blendiness. The 1/3 is technically out in front of everything. This 1/2 can be moved out to the front. So this is minus 3/2 of 3 squared minus 1 squared. And so only the x is what we really need to evaluate, but any constant coefficient can be pulled to the front, like a factor process also. Okay, 3 to the third minus 1 would be 26. 26 thirds minus 3/2 times 8. Yeah, I think that's 8. 9 minus 1 makes 8. So 3 over 2 times 8. 8 divided by 2 is 4. So 3 times 4 would be 12. 26 thirds minus 12. Hold up, that's 36 thirds. So 26 minus 36, negative 10 thirds. You can check it if you want. Go to Desmos. Evaluate the definite integral using technology, but that's your call. Thanks for watching this video.